Right, chapter 8 is all about right triangles and trigonometry. Okay, before we can get to trigonometry, we're going to talk about some basic right triangle stuff. Okay, section 2 is about the Pythagorean theorem and its converse. So in 8.1, we talked briefly about what the legs of the right triangle were and what the hypotenuse was. Okay, just remember that the side opposite the right angle that's our hypotenuse. Okay. Couple things. Actually, just one thing. It's always opposite the right angle, but it's always the longest side also. Okay. Now, the other two legs that make the right angle, those are called the legs. The other two sides that make the right angle are called the legs. Okay. And so our Pythagorean theorem in words says if a triangle is a right triangle, then the sum of the square of the legs is equal to the square of the hypotenuse. Okay, so first thing that has to happen, we have to have a right triangle in order to do the Pythagorean theorem. Okay, for it to be true. Okay, our legs we're going to label as A and B. Okay, and it says the sum of the square of the legs. So the sum means we're adding things. The square of the legs, we're going to square each of them individually, okay, and that sum is equal to the square of the hypotenuse. Alright, so when we're labeling our right triangles, you always want to label C first, okay? Think about what side do we have to travel all the way across the triangle to get to? Which side doesn't touch that right angle? Okay, that's our hypotenuse, that's our C value. And then between A and B, it doesn't matter which is which. All right. So if we look at the examples here, example 1, I'm going to travel all the way across the triangle. This is my C value. All right. Between 6 and 15, it does not matter which one becomes A and which one becomes B. Okay. So if I take A squared plus B squared equals C squared, I'm just going to substitute values in that I know. Okay, I made 6 my A, I made 15 my B, and right now my C is X. I don't know what C is. Okay, or what X is, I guess. 6 squared is 36, 15 squared is 225. All right, remember exponents come first, so we can't add 6 and 15 and then square it. We've got to square 6, square 15, and then add them together. So when we add them together, this is 261. And to get x by itself now, we find the square root. Okay, and this is where simplifying radicals are going to come into play. But if you're in class and want to use the yellow calculators will simplify the radicals for you. So this one ends up being 3 square roots of 29. And so that is the length of your hypotenuse. All right. When we've got both of the legs, this is what our solution is going to look like. Okay, we just substitute A and B, square each of them, add them, find the square root. Okay. Now, in number 2 here, we travel all the way across. This one I have my C value, and I don't have one of my legs. That's what I'm trying to find. Okay. So again, let's just start A squared plus B squared equals C squared, and substitute X for A, 9 for B, and 11 for C. Okay, exponents come first. 9 squared is 81, 11 squared is 121, and now I'm going to subtract 81 from both sides. Okay, that leaves me with x squared equals 40, and now we can find the square root of 40. Square root of 40, and the length of our second leg here is 2 square roots of 10. All right, try examples 3 and 4 on your own and check your work in the completed notes.